Hi all. We have completed our final project for the end term on SMS Spam filtering, and this is Team 10, consisting of me, Ronak Kumar, Ashwin R, and Adi Yogesh. So, in the coming slides, we'll be explaining our project on SMS Spam filtering. So, the first step in the project is data pre-processing. First, we have a raw data frame called as corpus. We after that we check and drop the duplicate words in that. The next step, we normalize the data, and after normalizing the data, we remove the stop words. After removing the stop words, the next step comes is removal of punctuations. The After this step, we perform stemming, and after that we have label conversion of ham and spam, whereon we convert ham into 0 and spam into 1. The step after that is checking and dropping the duplicates, and the final step is printing the final data frame. The next step is data exploration, wherein we see the distribution of the target variable. We can see that there are more ham messages than spam messages. The next thing that we can see is the message length. Here by the results we can see that the message length of spam messages is more than that of ham messages. In the next step, we have created a word cloud. So we can see the word cloud for ham. The most common words that were used in ham were normal associated relationship words. The second, we created a word cloud for spam, wherein we can see that the most common words in spam were words like free, claim, which are common spam words.
Since for model fitting we need numerical data, we need to convert SMS into numbers. This approach is called vectorization. We are using 4 different vectorization approaches in this project. In the first approach, which is called TF approach, each SMS is tokenized into words and frequency of words are noted to create a vector. This is done for all SMS to create a TF matrix. In the second approach called TF-IDF approach, the TF scores are multiplied with IDF score to create the matrix. The IDF scores proportionally change with number of words. For rare words, it will give higher weightage, and for frequently occurring words, lower weightage is given. Both TF and IDF scores are multiplied to get the TF-IDF matrix. In the third approach, we have used Google's word-to-vec algorithm. This algorithm will create a vector of size 300 for all the SMS, and the resulting matrix is now being used for model fitting. In the fourth approach, we have created our own binary features based on occurrence of words. For this purpose, we have taken words like free, claim, and price, which are common spam indicators. If a corresponding message has this particular word, it is marked as 1 and otherwise 0. After vectorization, we have performed dimensionality reduction step with the help of PCA. We were able to reduce the size of the resultant matrices, and we have also visualized the first two PCA components with colored labels. Same step is repeated for TF-IDF matrix and word-to-vec matrix.
Now we'll be doing data splitting for modeling purpose. Here the X will be SMS and Y the target will be labels, and we have taken 80% of data for training and 5% for validation purpose, and we are keeping with 15% for the test size, and we are giving a random state of 10, which is an hyperparameter for splitting the data. We have fit the models on TF, TF-IDF, O2 vector with respective gradient boosting, histogram gradient boosting, ADA boost, and etc. So out of these 21 models, we are discussing about the first 10 models here. The first model is on histogram gradient boosting on TF-IDF, where we have got the best scores here. We can see that train accuracy of 99% and FN score of 0.98 and precision of 1 and recall of 0.96. Whereas in this model, we have the ham messages are accurately, while only 19% of the spam messages has been misclassified into ham. Second model is on logistic with a TF vector. In this model, the ham messages are perfectly classified, whereas 22% of spam messages are misclassified. Third model is on hist gradient boosting on TF vector. In this, the model has similarly performed as on other models. Slight of misclassifications has been happened. Coming to the fourth model, it is on random forest on TF-IDF vector. The wrong classification of these spam messages has been marked as ham and it has been increased in this modeling. The fifth model is on decision tree on TF vector. In this model also it has performed as a similar like previous. There are slight misclassifications in this also. Sixth model is on random forest on TF vector. In this model, though ham messages are correctly classified, more number of spam messages are classified as ham. We have more misclassification in this. The seventh model is on AdaBoost on with TF vector. In this modeling, we have found slight misclassifications of spam and ham. The spam messages are classified as ham here. The eighth model is on gradient boosting on TF vector. It has performed well but slight misclassifications is present. The ninth model is on decision tree with TF-IDF vector. It has given a good accuracy rate of 97%, but we have still slight misclassifications here. The 10th model is on gradient boosting on TF-IDF vector, where we have a good approximate score of 0.88 and slight misclassifications are present. Here is a summary of all 21 models based on the FN score. Out of TF, TF IDF and vote to vector, TF vector is giving a good results with all the models. The first good model is HIST gradient boosting with TF IDF with an FN score of 88%. And similarly, the worst performance is on word to vector. All the models with word to vector has been giving a low FN score of 60% at the highest. We have fitted the test data which has been kept apart on the best model, which is on HIST gradient boosting. So from fitting this model, we have got an accuracy of 0.97% and FN score of 0.84, precision of 0.93 and recall of 0.77 and ROC of 0.88. Coming to the conclusion part, in this project we have showed you the necessary steps we have taken for designing the spam detection algorithm. First, we have explored and understood the data, then followed by the visualization of data and text pre-processing has been done. Followed by vectorizer using count vector, TF-IDF vector, O2vec and heuristic feature. Then splitting of data has been done into 80% for training purpose, 5% for valid purpose and 15% for testing. And the algorithms used here are decision tree, random forest, gradient boosting, HIST gradient boosting, AdaBoost and logistic regression. And for each algorithm we have calculated the score metrics using accuracy, FN score, precision, recall and ROC. The highest FN score was observed in HIST which is recorded of 0.88%. In general, all the models were performing better, but HIST has predicted ham messages as ham and they were not marked as spam. Thank you.